Calculus is double physics and a maths.
Yes.
What difference does it make? You're with me for 3 hours. It literally makes no difference. How does it make any difference? Is it? Is it really?
But you said they were going to teach us something.
Math is more fun.
Yeah, exactly. Maths is
Oh, yeah.
Physics is more fun. Maths is easier. Physics is more fun.
Agreed. Cool. Right. Have you talked much about uncertainty in chemistry? Chemistry labs. Errors, yeah. Yeah. We will have a full discussion on that in a different lesson, but I just wanted, since we're kind of doing mathsy physics stuff right now, I want to talk a little bit about the calculation that you may have to do in chemistry and will have to do in physics as well, called uncertainty. So here's the concept. When you measure something, like let's say you're measuring the height of a person, and let's say it's 1.5 meters, you all know it's not exactly 1.5 meters, because maybe you made a mistake, or maybe there's a problem, or something like this. So we have this thing at the end called uncertainty, which is like a plus or minus term. Yeah? So basically when we make a measurement x, we are uncertain about it exactly, and we call the uncertain part delta x. Or sometimes people write it like this, ux. I don't really like that. So example would be, your height is 1.5 meters plus or minus 0.001 meters. Now you kind of got this a little bit when you were doing the labs, because remember I said you have like L1 and L2, or T1 and T2. So the question is, how can you calculate uncertainty? There's a couple of ways to do it. So, let's start then. The first way, actually before I continue, did you talk at all about this in chemistry? So what are the ways you can find uncertainty?
Calculation thing. Data. And the division formula.
One way you can tell what uncertainty is whatever it says on the machine.
Yeah. This is the moment that has a 0.5
Yeah. Yep, that's what we'll do too.
No. In all the experiments, we will all have to do it.
Only the new
At least chemistry had a way of like to escape this. Can you just do a different experiment?
As I was saying, the first way you can find uncertainty is just read what it says on the machine. So for example, if you had a voltmeter, it might say on the machine plus or minus 0.01 volts. The first way to find it is see if it says it on the machine. Okay, so write that down. That's like the first method for finding uncertainty. This is the ways to find uncertainty, calculate uncertainty. It's not really a lesson because I don't have any questions for you. I'm just giving you some formulas and ideas.
So the rest of all this is not really fun.
You kind of did already though, when you were measuring like T1 and T2, yeah. But what I'm doing now, Wong, is giving you sort of more of a background to it.
So this is not how to calculate, this is only how to find it.
We'll get to how to calculate it, don't you worry. Okay. Yeah. Okay. The second method. If your machine does not say this, one way you could estimate the uncertainty is you can say the uncertainty is half the smallest reading. That's another way of doing it. So, for example, when you were looking at the meter stick, the smallest reading you could make on that technically, I suppose, is a millimeter, although you weren't using it accurately enough to measure to a millimeter. You were probably using the meter stick accurately enough to measure to half a centimeter, which meant the uncertainty was a quarter of a centimeter. So the four methods I'm going to show you, they get a little bit harder. So the second method is half the smallest reading. Yeah? Do you understand? No? Okay. So for example, let's say you have something like weighing scales. And here it's digital. Oh, I got a good example. The light box for measuring the speed. Do you remember? And here it has the speed. So it would say, for example, like 12.5 and the unit was meters per second. What's the smallest reading this could ever say? 0.1. Was it one or two decimal places? Two. Yes. I think it was two, wasn't it? So what's the smallest reading? 0.01. So that means the uncertainty in measuring the speed is 0.005. Now that's one way to calculate it. There are many ways to calculate it. That's just one way. Is that okay? Yeah. So that's the second method. But these aren't great. Now on to a better method, method 3. Another way to calculate uncertainty, it's the biggest value minus the smaller value divided by 2. Now we're getting more accurate in our estimation of uncertainty. Lamsip? No. Lamsip max? Good.
Is it this one? Because there were many maxes.
Yeah, there are different flavors.
That's the one. Okay. Now, this one here you used for pendulum. Actually, when I think about it, you used this for the 1, 2, and 3. You didn't use it for Newton. You could use it for Newton because I made you do everything twice, remember? But it's not so great because I wanted you to do a different way for Newton. So we'll scroll down and have a look at the fourth method. Do you have those 3 written down? Yeah? Okay. So the fourth method, this is when you make many measurements, for example. So you can't quite use this for Newton because you only did it twice. There's something else for Newton. But when you make many measurements, etc., the uncertainty is the average difference to, now I'm not being formal, I'm trying to keep it simple, okay? Trying to keep it simple. The average difference to the average. What the heck does that mean? Let me explain. Can I go to the spreadsheet? So let's say here I measure x, and let's say x is height or whatever. So here's x. Come on. Right. So let's say the first time I measure, I get 1.6. Then I measure again, and I get 1.6. Then I measure, and I get 1.61. Then I get 1.59, and then I get 1.62. So these are my measurements. So if I measure something 5 times, what is the best value I can use for my answer? Well, I should use the average, shouldn't I? So that is average, all of these. 1.604. Now, and let me just type in here, this is equal to 1.604. How far away was this one to the average? It was 0.004. This is the difference. Right? Okay, let me just get Excel to do that so I don't make a mistake. 0.004. The next one, the same. If I calculate the average of these, that's the delta. Yeah. 0.0088. Now, wait. Let's use a different method to see the different possible answers you can get. So, what do you do in method 3? Yeah. So let's compare it to that method. What's the max? This one. The min? Divided by 2. So you see it's different, okay? But I suppose the advantage of this method is it's quick and easy, but it's not really an accurate method. But this method here, so far this is the most accurate method for calculating the uncertainty. So what you do is you look at the difference between the data and the average, and then you get the average of that. Do you understand? Yes? Okay. Right, so these are the 4 methods. Of these 4 methods, which ones did you do in chemistry? So did you do this one in chemistry? No?
Suggested when we were doing.
It was suggested, okay. This one in chemistry?
Third one, yes.
Third one? Yes. And fourth one? No. Okay, so we have this one in common. Right. Now I notice you also talked about in chemistry what do you do when you combine measurements. Yeah. So can I scroll down? Not yet. Okay. So you didn't. So you could choose experiments where you didn't need to calculate this.
Yes.
Oh. Is that what most people did?
Coffee. No. That's what. What do you think?
You chose the experiment.
We were given the what we calculated.
You were given it, but you calculated it.
Like you had
The way.
calculation.
Okay. I understand you. Can I continue now?
It's like us in the math of the question of coursework. We were given it, but we had to solve it. YouTube video.
Fair enough. Alright, continue. Right, so what do you think happens if you use a measuring device twice? So for example, let's say you had a meter stick, so you have to measure the person once, I don't know, or whatever you do, you measure it twice. So there's one measurement here, we'll call it x1, and then you measure again and you call it x2, and you say his height is x1 plus x2. But each time you measure, you have an uncertainty. So my question here is, what is the uncertainty for the h? Is it this, both of them, average of them? Do you talk about this in chemistry?
Yes. Yeah,
So what-
you showed us what do we do when we add them, when we multiply them, and subtract them, and when we divide them.
Okay, so what do you do when you add them?
I wasn't really listening.
Okay, great. No. Well, kind of, but not at first. There's an easy way to do it. Think about it like this. Let's say I measure something and it could be 1 meter plus or minus 1 centimeter, right? And then I measure it again and it's 1 meter plus or minus 1 centimeter. And I add the two answers together. So the total height is 2 meters. In the worst case here, we could be 1.01 and 1.01. That's the biggest case. If we were this wrong twice, then we were off by 2 centimeters. In the smallest case, what would we be here? 0.99 and 0.99. So we're off by, in total, 2 again. So in other words, it simply adds. So when you make 2 measurements and you add them together, you add both answers obviously to get the final answer, but the uncertainty adds as well. So this is what you do when you want to add them. Okay, so clearly you weren't listening during this lesson. So write this down, please. Your chemistry teacher will be so pleased to know this. Yes?
Is this the fifth method?
No. There was 4 methods for calculating delta x, and now we're looking at how to combine them. So for example, this is the situation where you add 2 measurements together. The uncertainty adds. Continue. Continue. Yeah? Okay. So what about in the minus case? So for example, you make a measurement and then you make another measurement, and your answer is the difference between the measurements. What do you think the uncertainty would be? Would it still be add or would it be minus? What do you think?
It'd be add.
Still add them. Yeah. It's still the same. The uncertainty still adds. Okay. You're confused. No? You're unhappy. No? Okay. So if you think about it like this, let's say I measured this is 1 meter plus or minus 1 centimeter, and this is, I'll say, half a meter plus or minus 1 centimeter. Then how much is this? Well, it's half a meter still. But you could be wrong by 2 centimeters because this could be wrong by 1 and this could be wrong by 1. You know, this could be shorter by 1, which would make this shorter, and this could be longer by 1, which would make it shorter by 2.
But it can be perfect, right? It can be perfect. Like if this was a plus 1,
Measurements can never be perfect.
no, as in if that was plus 1 and the other one was minus 1.
Oh yeah, by
would it
pure accident, the 2 uncertainties could cancel. But you would never know when or if that happened. You have a better chance of winning the lottery. Okay. Continue? Yes? Alright. So what about now more complicated cases? Like for example, if you had some measurement, let me just call it y, and you have to multiply two, sorry, you want to calculate y, and you have to multiply two measurements together. So how does the uncertainty combine here? Does anyone know this one?
No, now you use the roots and the squares.
Yes. So now the problem is getting a bit more difficult. We start to need to use a special formula. So when we have situations like this, what do we do? Well, I'm actually going to make it more general for you. I'm not only going to say when they multiply together, but I'm also going to say when they have powers too. Yes? So for example here, power n and power m, you can find the uncertainty of y by using this formula. Uncertainty of y over your value of y equals square root, let me see if I remember this correctly, I believe the n is inside the brackets, n uncertainty of x1 over x1 squared plus m uncertainty of x2 over x2 squared. So for example, if n equals m equals 1, then you have this formula. Delta y equals y square root delta x1 over x1 squared plus delta y1 over y1 squared. Now what's great about this formula is it's so flexible because we can use this for dividing as well. Please write this down before I continue. Sorry, that's an x. What's the zoom in? Delta x2 over x2 squared. Example. This is the multiplying case. Yes, but we'll see why now.
Why is there a y before?
I just cross multiplied the y. Can I continue? Hang in there, Yusuf. If you want to be the next Cisco Ramon, you're going to really need to study hard. What do you want to study at university? Cisco Ramon is an engineer. You can be the Cisco civil engineer. Okay, continue? Yep. Right. So what about dividing? x1 divided by x2. Well, you can change that into x1 power 1 times x2 power minus 1. And you can use the formula I gave you a moment ago. So that would be square root 1x... What? Thank you. 1 delta x1 over x1 squared plus minus 1 delta x2 over x2 squared. And then you realise, so that's why it's the same. It's still delta x1 over x1 squared plus delta x2 over x2 squared. Yeah. Now we need to practice these formulas, which we're going to do now in a moment. Yep.
Minus 1.
Yep.
Why did you remove it from the...
What's minus 1 squared?
Oh, nice. No, wait. You're only
no.
removing the minus 1 from the equation. And you're keeping the... So it's not bad.
There we go. Okay. Did you write that down? Yes? No. Let's have a look at some examples. I'll start. We'll take turns.
No, thank you. You can keep on going.
No, that wouldn't be fair. That wouldn't be fair.
No, it's fine. It's fine.
No, Faisal. No. Question 1. So, simple example here. A student measures the height of a wall or a door or whatever, and they have to use a meter stick twice. So they use it once and then they use it again. So the first measurement they get is 1 meter, obviously, and then the second measurement they get, we'll say 0.4 meters. Now, the uncertainty is the same in both cases because they're using the same meter stick. And what do you think the uncertainty is? Which of the 4 methods could we use? Well, we could just the first one, but the meter stick doesn't say it on it, so we can't use the first one.
Second.
The second one, where it's half the smallest reading. So what's the smallest reading you think the student could accurately use the meter stick for? I think they could do a bit better than that. I think they could do half a centimetre, because half centimetres are marked on it as well. Yes. Yeah, it looks. Yeah, it is. Okay. So I would say the uncertainty is the same for both measurements. 1/4 centimetre. I want you to calculate the height of the door and the uncertainty in that measurement of height. So in other words, I want to know x with the plus or the minus. It should only take you 10 seconds.
1.4 plus or minus 0.5.
No. Give me the same units.
1.4 meters
No.
plus or minus 0.0005. No, bro, 5.
Could you add them? Yes. 0.0005.
It's 0.25 centimeters.
Yes.
So 0.0005 meters.
0.005. 2 zeros only. You're sticking to this. You're really saying it's true. No, wait. Let him figure it out.
If it is 50 centimeters,
Yeah.
it is 0.5.
Correct.
If it is 5 centimeters,
Yes.
it is 0.05.
Yes.
If it is 0.5 centimeters,
Yes.
it is 0.0005.
Which is what's written on the
No, that's not what's written on the
Yeah,
board.
you just have 2 zeros.
No,
Yes.
it's great.
Yes. 0.005. Isn't that what you just said? Did you all hear that? Yeah. It's all. Yeah.
Okay, if you want to.
This is 1/4 centimetre, correct? And what's twice 1/4 centimetre? Half a centimetre. What's 1 centimetre? That's 1 centimetre.
Yes,
Yeah, so half a centimetre.
that's what I said.
Yes, it is. We all make mistakes. It's not to be ashamed of.
Not ashamed.
Good.
Faisal now learned from Faisal 3 seconds ago.
Good. Right, okay. Are we okay with this one as a basic example to start with? Question 2. So the next one. We'll make it a little bit harder. This time, a student wants to measure the area of something. So again, they use their trusty meter stick and measure this to be 0.6 plus or minus 0.0025 meters. And here they measure this side to be 0.5 plus or minus 0.0025 meters. So my question is, what is the area with the uncertainty of the area?
I have a question.
No. I
Serious.
will answer it after you do this one.
But it's kind of about this one.
No, because you use the word kinda, I'll answer it afterwards. After you do it.
I will throw
Andrew, you know what to do?
Yeah.
Okay. Do you want to do it?
I'll do it in a second. This is the delta y. What's the y again?
In this case, it'd be the area,
Oh.
because this is what you're getting.
The area without the certain uncertainty.
Correct. Yeah.
That's big.
What is?
That's not that big, it's small. But 0.95 times 10 to the power negative 3.
Yeah, believable. Okay, are you ready for this one? Ready? Okay, so what did you get for the area firstly?
0.3 meters squared.
Because it's just that times that. Now let's calculate the uncertainty. So we have the formula: uncertainty of A over A equals square root uncertainty of x1 over x1 squared plus uncertainty of y1 over y1 squared. So I'll just bring the A up there and multiply it. So that is 0.3 square root that squared plus that squared, and then here fraction 0.0025 over 0.6, and this one here 0.0025 over 0.5. So you got this 1.95 times 10 to the minus 3. So that's 0.00. Yeah, I know, I fixed that. Plus or minus 0.00195 meters squared. Yeah, did you get that? Okay. Now, let's make it.
Question?
Yeah.
Okay. Those, we do this when they're the same unit. If they're not the same unit and we multiply or divide, do we still do this?
Oh, I see what you mean. When they're different units, like one is length and the other is time or something like that. Yes, the rule still applies. You just have to be really careful with what you have as the units in the answer. So, like, you mean like, for example, let's say this was seconds and this, it's kind of, yeah, okay, seconds and, I don't know, force or something like newtons. You mean something like that?
Meters.
Yeah, tell me what you want here.
Second, meters.
Meters, okay. Now, if you look at this formula, you can see that as long as the uncertainty of the measurement and the measurement itself are the same units, then all the units cancel here.
Yes. Oh. Then why do we write meters square on the end?
Inside the square root, the units cancel. But the uncertainty of A is equal to A times this thing which has no units.
So the A is the unit. That's the same. So it still applies for different units.
Right. Question 3 now. I'm going to give you a formula that looks familiar. T equals 2 pi root L over G.
Okay, another question. Sorry.
Okay, make it good.
If we are, let's say we're given this pencil is measured and we get this, and then they say we have 3 different exact same pencils. Do we multiply this uncertainty by 3, or do we do them for each one?
That is not a real problem because the pencils will never be identical.
Yeah, but like if they are saying that a square, let's say, they tell us that it's a square, but in reality it is not a square.
Well, I'm not sure what your question is.
I give you this pencil,
Yeah.
and I'll tell you this is 5 centimeters,
Yes.
and the uncertainty is 0.01.
Okay.
And then I tell you you have 3 of those
Yes.
pencils. And then you're supposed to find the total length and the total uncertainty.
The uncertainties add, so yes, 3 times the uncertainty.
Because you're adding them.
Yes. Which is one of the rules I gave you. Okay. So here, what uncertainties did you know when you did this experiment? You worked out the time, so let's imagine, I'll just make up an example. I'll say the time is 2 seconds. And we'll say the uncertainty in measuring the time, do you remember what type of number you got? It was like it would be something small. We'll say 0.1 seconds. Let's say the length is 1 meter, and the uncertainty in the length would say is 0.0025 meters. My question here is find G and the uncertainty of G. So now we're getting a bit harder. Try this one. Sleepyheads. Fan time, maximum power. This will help. Yes. 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 Well, I really just needed it on these two. And me, so. Did you do this? Yes.
Tonight meditation. Oh, what happened to your meditation?
The meditation?
Oh, you told me about this already.
I have no idea what you're talking about.
Books.
What?
Books. Not books.
Oh, yeah. I never meditated.
How do you cancel square root?
You know how.
Certain
Square it, yes.
but do I have to wait until I just
Can you just what?
You're picking up bad habits from Faisal sitting beside you.
But not too much waiting on
Oh my goodness, you're the
and for nothing.
whiniest bunch of physics students ever.
Not worth it.
I'll tell you.
Yeah.
You're thinking of this as worth it? The uncertainties? You have to do it for physics, for chemistry,
Yeah.
preparing you for university.
I was
Reference this and reference that, preparing you for university.
This is preparing you. This is what you do at university.
They don't really...
No, what I'm going to do in the next lesson is much more advanced than this. But before I do advanced stuff and blow your mind with Excel and calculating of regression lines, I need to give you the basics. Walk before you can run.
Yes,
But I
my
do
point.
before I run.
It's the basic.
I'm just going to ignore you now. It's going to be difficult, but I'm going to do my best. Okay, so we are looking for G and delta G. So let's rearrange this. t squared equals 4 pi squared L over G, correct? So that means G equals 4 pi squared L over T squared. So that means G equals 4 pi squared L1 T minus 2. Yes? Now before continuing, let me just calculate what the G is from this formula so I can do this part. G equals 4 times pi squared, and then what's next? Times L divided by 2 squared. So I get 9.8696. Next I want to calculate this. Yes? Now, I can use my formula, but please watch carefully. Delta G is what I want, over G. Do I know G? Yes. Now, if you look at this formula, it's kind of like you have 4 terms in it. 1, 2, 3, 4. So it will be square, 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 square. Now the first one's a bit tricky, but I think you'll get the idea. It's 1 times, and then we have 4 on the bottom, and what's the uncertainty in 4?
0.
Yes, 4 doesn't change. 4 is a 4. 4 is never nearly 4. 4 is always 4. That's right. You can quote me on that. 4 is always 4. Here is 2 times pi here, and on the top?
0.
Because?
Pi.
Yay! Here we have 1. On the top we have 0.0025, and on the bottom we have 1. And here that's a minus 2, and on the top we have 0.1, and on the bottom we have 2. Now these cancel. So you get delta G equals 9.8696 square root 0.0025 squared plus 0.1 squared. Can you hit that in on the calculator, please? Oh my goodness. Square root 0.0025 squared plus 0.1 squared.
I got 0.987.
87. Yeah. Yes?
Yeah.
So the answer is G is equal to 9.8696 plus or minus 0.987 meters per second squared. Now that's a really big uncertainty, and the reason it's so big is I probably made one of my uncertainties too big at the beginning. I think my L is right, but I probably made my T too big. It's probably better than 0.1. Maybe it's more like 0.05. I'd say. I don't remember because you have the data. Does anyone have their laptop with them?
Isn't because the stopwatch has the 2 at least
You do it twice.
That's what they do.
Here, give me the calculator here, please. Do you remember how different your 2 answers were when you did the experiment with the...
Way different.
Oh, it's more than a second.
More than a second?
No, less than a second. It's like 0.5 seconds.
0.5, yeah. And then that is for 10 oscillations. So for 1 oscillation?
0.04.
Yeah, over 10.
0.005.
No, it's over 10.
Over 10, so 0.05.
No, it's 105.
It was 0.5. The difference between T1 and T2.
Oh, but you said 0.1 is too little, so you want to take 0.05. It's just
No, I said 0.1 is too big.
Yeah, it's too big, so you want to take something smaller.
Yeah, so 0.05. It's smaller than 0.1.
Yeah, so 0.05 is for the 10 divided by
No,
10.
0.05 for the 10 is too much.
You said 0.1 is too much for the 10 or for the 1?
For the 1.
Okay.
Thank you.
Because it was
Is that okay, guys?
you want multiply, you don't want to define.
Andrew? Lee? No, Lee's gone.
Oh yeah, it's gone. Like this.
He's long gone. Come on, Andrew, don't be a Lee here.
I'm listening.
Alright.
I'm really,
Questions?
you know?
Come on. Come on, what's your question?
But why T is 2?
-2.
Where? Here?
No.
Yeah, why from that?
Did I not say it in the question?
Yes. No, she's talking about the power. That's why the.
Oh, here?
Yeah.
Oh, because here.
Why?
Because I square.
Why?
Why? Because I want G.
Why? Why do you want to choose?
Because that was the question.
Why does the question want to choose?
But if you
Delete
only
the question.
learn from that equation,
Say again?
what? If you only
Yeah.
learn that equation,
Yeah.
not square like that.
Oh, but I need the G.
Yeah, but like when you learn it and then when
Yeah.
it's only square root of L over G, that can you square.
I have a banana and an apple.
But,
That's the square root and.
yeah, you see, in this
It's
question, normally we want T, but in this question we were given T and we were given L, and I'm looking for G.
Yeah,
So I don't want the G here, I want the G here.
yeah.
Okay.
Like I mean, from here, square root in here, not in the big E.
Oh, put the numbers in first.
Yeah.
Yes. You can do that. However, if you do that, then you can't do this because you don't know what the powers are. So you can do that to find G, but you can't do that to find delta G.
Just in here.
Yeah? Yeah, that one was for multiplying only. Okay.
You want to see our experiment?
Show me.
I'll just delete now. In slow motion.
What? Did I press time?
No, slow motion. You woke up for this.
I don't know what I would do without you. Right. Yeah. Let me give you one more 5 maths. Can I close this?
Yeah, no.
Now put that away. I want you doing maths.
If I score this, will it just be lovely?
Half past.
Oh, yeah, so
Come on.
you don't score it, we don't jump to.
Bismillah. Allahu Akbar. The rest of it is like I don't want it to spill around.
okay, let me spit on Andrew, it's fine.
Okay, thank you. Can I stand up?
As you wish, whatever will help.
No, Andrew, you need this.
I've been waiting for Matt all day.
Smash it into his face
We'll do math.
until half past.
15 minutes?
Yeah, please don't, really sick.
Do it for your friends, please.
Yeah, yeah.
Only for you. You're traveling to
You do it for me.
What the heck is
That's just we throw him next.
Yeah, I
Get
just
him
put
in.
him in the bin.
Just let us go and keep him.
I can do this.
No.
Why would you
I
think I just
think
like this?
Yeah, of course, we'll leave.